Hello everyone, welcome to Yourpedia Education. So as you know, BEL released a notification for 350 vacancies, right? And for electronics there are 175 vacancies. If you want to prepare for that one, I'm here with one video that is an analog integrated circuit, that is 555 timer and its application. It is a very important topic for that one. Last year he asked 1 or 2 questions from that one, and basically generally if you are going for the GATE and other exam, we generally not consider this one as an important topic. So that's why I come with this video and I will discuss detail about this one. What is that 555 timer IC, what is the internal circuit of that one, what are the different application of that one, right? In how many modes it can work, what will be the frequency of oscillation, and everything we are going to discuss. And after that we are having around 30 questions for your practice, so you can do the practice for that questions also, right? So basically this is analog introduction to analog integrated circuit. So before moving to this one important thing I have to discuss with you, that if you want to prepare for BEL, this is really important how you start your preparation. Sir already make one video, Vijayender sir already make one video on that one, that how you have to prepare. You have to prepare vast of things but not that much depth. You have to know the basic knowledge. If you are thinking that you can't do the good in GATE exam but you can do the good in BEL exam, it is not the exam where he asks the question from depth and depth and depth. No, he is asking more things, and you can say you have to prepare horizontally and you have to touch the basics of everything. You should know the basic of everything and you can easily crack this exam. I already uploaded one video, right? That is the solution of last May 2025 exam. That is very easy exam. You can get an idea from that one that this exam is easy, but I'm not saying that this exam is easy if you leave something. You have to touch everything. He asked the questions from any corner of your institute like that, because syllabus is not specified there, but what we observe from the last trend, what we observe from other exam which was taken by the BEL, we make a comprehensive syllabus for that one. We already given this syllabus in our free WhatsApp groups, you can check there. And if you are not in the free WhatsApp group, you can join the free WhatsApp group. Link is given in the description, right? So basically let's start this. This is introduction to analog ICs. What is analog ICs? That is the circuit in which all component like transistor, resistor, capacitor, diode are formed on a single chip, right? Single chip, right? Fabricated on a single semiconductor chip. This process continues signals, right, very smoothly, so that we can get a output for their types of ICs. There are 2 types of ICs. One is linear IC. The linear IC is generally known as analog IC, right? Another one is digital IC. Digital IC, and what is the difference between analog IC and digital ICs? Analog ICs will work on the analog signals. Like we are talking about 555 timer, voltage regulator ICs, transistor ICs, operational amplifier ICs. These ICs generally analog ICs because they are operated in continuous time signals. And another one is digital ICs. Digital ICs generally work on digital signals like zeros and ones, right? And like logic gates, flip-flop ICs, microcontroller ICs, these are the example of digital ICs, right? Characteristics of analog ICs. See, basically the first characteristic, highly reliable and compact in size as compared to digital. Their low power consumption, their cost is low, capable of amplifying, oscillating and signal conditioning. That is the most important properties of your analog ICs. Importance of analog ICs. Basically, if I'm talking about your communication system, generally communication system or radio system you are talking about. In radio system, we are transmitting an analog signal from the transmitter end. At the receiver, we are receiving an analog signal. So what should we do? We have to make all the component at transmitter and the receiver side at an analog point of form, you can say. So what we should do? We should use the analog IC for doing that one, right? So Yeah, this is analog IC, this is digital ICs. Almost you can visible the difference between them. This is the mixed signal IC. Microcontroller is look like this one. Memory ICs look like this one. Power management ICs are look like this one. So this is ICs, different types of ICs. Now the basic overview of 555 timer IC, right? 555 timer IC is one of the most popular and versatile analog IC, right? It is generally used to generate the waveforms like square wave, right? If you are using as a Astable multivibrator, Bistable multivibrator, Monostable multivibrator, it generates the pulses. It also work as a oscillator, right? And what are the features of that one? It can operate only for this range of voltages. Sometimes he asks you the question that what is the voltage range for this 555 timer IC? That is 4.5 volt to 15 volt supply, and it will take as a source or sink as a 200 milliampere output current, right? It can adjust the time delay from microseconds to hour, and the main thing, it will be made up of TTL logic family, right? We are using TTL here. It is low cost and easy to use. Type of packaging, it is having 8 pin inline packaging. Like you can see here, we are having 4 pin this side, 4 pin outside. So on the surface we are having 8 pins, right? That names of the pin, one is ground pin, right? That is connected to 0 or negative voltage terminal. Trigger is there and output is there. So there are several things. The 4th pin is reset pin. Fifth pin is control voltage, threshold, discharge, and VCC is the 8 pin. So these are the name of all the pins what you are seeing here. This is the first pin, that is ground. Second pin is trigger. Output pin is third. Fourth pin is reset. Eighth pin is VCC, and 7th pin is discharge, and threshold and control here. So this is the block diagram of that one, which is the function of each, you can say, the pin here, right? Internal structure, what we are seeing here, this is the internal structure of a 555 timer IC. Inside that one we are having a SR flip-flop. This is the transistor which is used to reset that thing. This is the output, which is inverter here, which invert the output and give the output. This is a transistor here. This is called as discharge transistor. Discharge means when this transistor is on, it will discharge the output and give the output as a 0. And everything, this is the control input, this is the threshold, this is the trigger here, right? All the pins, and what is the function of that pins which we discussed here, right? So basically this is the pin diagram. No, not pin diagram, the internal diagram. 555 timer consists of 2 comparators. These 2 things are comparators. What you are seeing, this one is comparator, upper comparator, lower comparator. What is the function of a comparator? It will compare the input, right? The input given to this is only a op amp, right? Input at the negative terminal and positive terminal. If the input at positive terminal is greater than the input at negative terminal, then output will be 1. If input at negative terminal is greater than the input at the positive terminal, then output will be 0 for this comparator. So that is the function of comparator here. SR flip-flop, you already know that what is the function of SR flip-flop. SR flip-flop is a flip-flop which will give the output based on this SR values. We are having the truth table for that one, right? Next thing. Okay, a flip-flop and discharge transistor, a voltage divider network consists of 3 resistors. This is the voltage divider network. This network divides the voltage into 3 parts. This is R, this is R, this is R. So basically, what is the voltage here? That will be VCC by 3. What is the voltage here? That will be 2 VCC by 3. Right, and here is the voltage is VCC. So this is called voltage dividing network here, right? This is consists of 3 resistors. Next is operation principle. The voltage divider create a reference at VCC by 3 and 2 VCC by 3. Trigger compare the input with the pin 2 with VCC by 3. Threshold comparator compare the pin input with 2 VCC by 3, and flip-flop store the logic state, and discharge transistor discharge the timing capacitors when it is required. The Now we are having different mode of operations. I'm not going in that much that what are the mode of operations, how they are working there. We are no need to go in that much depth, right? We have to understand the thing. See, basically this one is used to produce a single pulse of fixed duration. It will generate only a single pulse of fixed duration, right? How much is the duration of this pulse? That is t is equals to 1.1 RC. Right. So this is called as monostable mode. Monostable means one short mode or monostable mode. Monostable mode means it is having only one pulse. It will produce only one pulse at the output whose duration is 1.1 RC. Right. And used in pulse generator and time delay circuit. Time delay circuit is also there, right? So if you want to produce time delay in any circuit, you can use this one. Next is Astable mode, free running oscillator, you can say, right? Timer continuously oscillate between two voltages, high voltage and low voltage, right? Like this. So this is called as free running oscillator. It will generate a square wave at the output. Here we are not require any external trigger. Frequency is F is equals to 1.44 divided by C RA plus RB. We are discussing in detail what is that one, what is RA RB, right? We are making the circuit later on. The duty cycle for this one is this, and it is generally used to generate the clock pulses for the flip-flops and the circuit where we require the clock pulses, right? LED flashers and tone generators, it is also used. Next is bistable mode. This is called as flip-flop mode of the you can say the 555 timer. Output has two stable state. Two stable state means what? If it is going to be high, then it is going to be high. If it is going to be low, it is going to be low. It is having two states and both the states are stable states. So that is called as bistable mode, right? It is also known as flip-flop mode because flip-flop is also having two output, either 0 or 1, right? And memory elements, you can use that one. So first we discussing about the monostable mode, that circuit diagram. See, in this monostable mode we are using R and C capacitors here. What you are seeing, we use this, the internal circuit is there. I am using that pin diagram which you are seeing that internal circuit previously. So I use that 555 monostable mode. This is the 555 timer, and outside we connect a resistance R1 here and a capacitance C1 here, right? C2 capacitance is discharging capacitance. That will not make any sense, means any difference, not sense, it is having a sense. So this resistance and capacitance make this 555 timer work in the you can say the which mode? This mode is Astable mode, right? Okay. So basically whenever you work in this mode, we need to provide a trigger pulse. First we provide a trigger pulse, then capacitor is start charging and it will charge up to, this capacitor will charge, this VC is start charging and it will charge, because here is the voltage is 2 VCC by 3. So it will charge up to 2 VCC by 3. Then as it reaches to dVCC by 3, then your flip-flop will go into reset state. It will reset and this capacitor will start discharging. This negative trigger pulse start and this capacitor will discharge suddenly, and output will be +1 until this will reaches to 2 VCC by 3, then it will be discharged like this. So if you calculate the time will be 1.1 R1 into C. So this will decide the time, because this capacitor will charge through this resistance and it will try to go up to this VCC value, but as it reaches to 2 VCC by 3, your discharging circuit will activate. This capacitor again discharge and goes to 0. So we are having charging only, no discharging. Discharging is fast and it will go to 0, and at that point output will again going to be 0. So this mode is called as Astable mode because it is not having a stable output. This is called monostable output, right? And it will generate a pulse there, right? This is the complete discussion about this operation and everything about that, right? Okay. Next is, sorry, this is monostable mode, not Astable mode. Next is Astable mode and circuit and all about that. Okay, in this one we are using two resistance R1 and R2, and we are using a capacitance which are connected externally. Discharging pin connected between R2 and C. Discharging pin is connected between R2 and C. So as this discharging pin, this will discharge, so this completely discharge through this one, you can say the pin 1, right? Okay, in this one what is happening? In this one what is happening? Capacitance is start charging through R1 and R2. When the voltage again reaches to 2 VCC by through, discharge transistor which is connected in the circuit or inside the 555 timer, that will be conduct, and the transistor or capacitor will start discharging through R2 until the voltage is drop is to, see what is happening, there are two thresholds like this. One is VCC by 3 and again 2 VCC by 3. Right. So first capacitor charge up to 2 VCC by 3, then capacitor discharge, charge, discharge, charge, discharge. So this process is a continue, right, repeating this process, and output will be first plus VCC, then minus VCC, plus VCC, minus VCC, plus VCC, minus VCC. So output will going to be what? A square wave. So what it will do? It will generate a square wave at the output. So that's why it is called as free running oscillator. We are not requiring any external trigger for this mode, right? So that's why it is astable mode, right? Astable. There is no stable state. So oscillator, output will be oscillating between 0, 1, 0, 1 like that. Plus VCC, minus VCC, plus VCC, minus VCC like that. Okay. Next is bistable mode. In this there is no capacitor there. There is only resistances are there, right? And output toggles between high and low on trigger and reset input. When you give trigger or reset input, it will be goes like this, right? So we are having set and reset. If you want to set, it will give you the 1 output. If you do the reset, it will give you the 0 output. So according to this switch, you can adjust the output, right? That's why it is having two stable states depending on the input. If you are giving the set input or a reset input, according to that one, it will give you two outputs, right? Application is toggle switching, memory latch and frequency divider circuit and debouncing circuit we generally use for that one. So this is the another mode of operation of the 555 timer, right? So practical application of 555 timer, LED flasher, we generally use a astable mode where LED is blinking periodically, right? Touch switches, monostable mode, generate a signal pulse when you touch. So when you touch that touch switch, right, it will generate a monostable, so means it will generate a single pulse and switch will be on. PWM generator, astable mode we generally use, frequency divider, bistable mode, time delay relay we use a monostable mode, and light and dark sensor we use monostable, alarm circuit we use the monostable mode for the transistor, right? Advantage and limitation. So simply it is easy to use, operate over a wide voltage range, high output current, drive capability, stable and reliable operation, low cost and widely available, right? And limitation its frequency is only for 500 kilohertz. Above that one it will not work. It is very temperature sensitive, moderate accuracy, not suitable for high precision timing, and this is the conclusion, right? And some of the questions are there. What is 555 timer IC was invented by? In the starting I told you that is Hans R. Kamenjens, right? And 555 timer IC is explain is this is a mix IC, right? Mixed signal IC. Mixed signal IC, why? We are having a comparator there. Comparator means op-amp. Op-amp is an analog circuit and we are having a SR flip-flop. SR flip-flop is a digital circuit. That's why it is a mixed IC. 555 timer consists of how many pins? That is having 8 pins. Input voltage range is 4.5 to 15 volt, and pin 1 of 555 timer is what? That is a ground pin. The main function of trigger pin in is to start the timing intervals, right? Like that. So these are the several questions you can check and go through these all questions. Control voltage pin number is what? That is 5th pin here. Sometimes they ask you the monostable mode of 555 timer will produce. See, always remember all of these 3 modes, what they produce at the output. This will produce, the monostable means single pulse. The pulse width The pulse width in monostable mode is given by what? 1.1 RC. Astable mode, the output of 555 timer is how much? That will be alternatingly high or low, right? Astable mode. The frequency of astable mode is 1.4 divided by R1 plus twice R2C. Bistable mode of 555 timer is act like a flip flop. This question may ask, right? What is the output pin of 555 timer? That the third pin. The reset pin of a pin number is 4. Discharge pin, right? The output current of a 555 timer can be 200 milliampere or 500 milliampere, generally 200 milliampere. The three internal resistance of 555 timer, each of having value, see, always remember that is having 5 kilo ohm, right? Total internal resistance of a voltage divider circuit, that will be 15. The output can be driven which type of load, that is TTL or CMOS circuit, right? The time period of astable mode and like that, right? So this question you should go through. Which capacitor is usually connected at min 5, that is 0.01 microfarad. The output waveform as astable, that is a square wave. The main application of monostable mode is time delaying circuit, right? The bistable mode capacitor is not used, right? 555 timer can be a function of a oscillator, it can work, it can as a flip flop, it can as a pulse generator, all of the application. The maximum operating frequency, that will be 500. The IC number of any 55 is TTL version. CMOS version of a, that is LMC55. So these are the questions and this is the topic. This is the most important topic. You can go through that one, right? If you need any help, you can join Yourpedia. Yourpedia is also start the classes for this one, right? The BEL exam. This is not an easy exam if you are not preparing for that one, right? You are thinking that if I am preparing for GATE, I can easily crack this exam. No, it's a different exam. You have to prepare for that separately. And what you have to prepare, we already start the classes for this one. You can join Yourpedia, where you can actually get the which type of questions the BEL will ask you in future, and we are providing the study materials for that one also, like this I bring with you, and some you are getting the test series for that one also. So hopefully you will join that module and you can get the benefit from that one. So hopefully this video and this information is help you in your BEL preparation. Thank you.